Hello everyone. In today's lecture again we will continue chapter 3. So in previous lecture already we have discussed about aggregate, like what is aggregate, different qualities of aggregate, also different characteristics of aggregate, then what are the properties of aggregate which influence the concrete, again fineness modulus of coarse aggregate, also fine aggregate, and again different types of or aggregate based on shape of aggregate and size of aggregate. So first one is already discussed, that means types of aggregate based on shape, already discussed. So today's lecture we are going to discuss about types of aggregate based on size. So based on size, these are of two types. One is fine aggregate, another one is coarse aggregate. So let us discuss one by one. So first is fine aggregate. So when the aggregate is sieved through 4.75 mm IS sieve and the aggregate passed through it is known as fine aggregate. That means whatever, if the aggregate pass through 4.75 mm IS sieve, then this aggregate are known as fine aggregate. Natural and is generally used as fine aggregate, natural sand, silt, clay. So these are some examples. The purpose of fine aggregates is to fill the voids in the coarse aggregate and to act as a workability agent. Next is coarse aggregate. Similarly, it is the opposite of fine aggregate. So when the aggregate is sieved through 4.75 mm IS sieve, and if the aggregate retained on this type of sieve, this is known as coarse aggregate. Example, gravel, cobble, boulder, etc. And the maximum size of aggregate used may be depend upon some conditions. In general, 40 mm size aggregate used for normal strengths and a 20 mm size is used for high strength concrete. So these are the types of aggregate based on size. Next is what is grading of aggregate, or why the grading of aggregate is necessary. So the particle size distribution of aggregate as determined by sieve analysis is known as grading of aggregate. The gradation of aggregate plays a vital role in governing properties like workability and finishing of concrete. If all the particles of an aggregate are of uniform size, then compacted mass will have maximum voids, whereas particle of different size leads to dense mass. And the particle size distribution of aggregate should be in such a manner that voids of larger particles are to be filled up with smaller particles. Also, proper grading of aggregate results in dense concrete and requires less quantity of fine aggregate and cement paste. So, grading of aggregate affects workability, which in turn controls the water and cement requirements, segregation, and plays an important role in placing and finishing operation of concrete. Next is types of grading of aggregate. So it is depend on different sizes of particles available in the aggregate, and the grading may be of the different types as discussed, like well graded aggregate. So the aggregate is said to be well graded if the voids created by large size particles are filled almost by smaller size particles, hence leaving minimum voids to be filled by cement paste. The well graded aggregate contains all sizes of particles, thus leading to a compact and a dense mass of concrete mix. And this type of grading is considered the best because all sizes of particles are available, which leads to a lesser quantity of cement requirements. And next is gap graded aggregate. So when the particles of certain sizes are missing in aggregate, then the grading is termed as gap graded. And most of the crushers in India are single size crushers, thus creating single size aggregates. And the gap graded aggregate does not affect compressive or tensile strength of concrete. Next is poorly graded aggregate, the aggregate in which the proportions of certain intermediate particles are deficient or present in excess amount. This is known as poorly graded aggregate. And the last one is continuously graded aggregate. So the aggregate is said to be continuously graded when it contains all particle size groups, that means from the maximum particle size to the minimum particle size. Such grading is termed as a coarser or finer depending upon the higher proportions of coarser or finer particles they contain in reference to specified grading with which they are being compared. So these are the grading or different grades of aggregates. Also there are different factors which affect the grading of aggregate, like density of aggregate, segregation of aggregate, bleeding of aggregate, strength of aggregate. So these are some major factors which are also affect the grading of aggregate. So with this the aggregate part is completed. In next lecture we will continue with the next part of this chapter. This is water. So thank you.